Hello everyone. Today we are going to present our research project, Smart Gloves for Parkinson disease. The main objective of our project is to develop a glove capable of detecting and reducing patients' tremors in order to improve their autonomy and help monitor the progression of the disease. Parkinson's disease is another neurodegenerative disease that affects the nervous systems. It causes tremors, muscular stiffness, movement difficulties, and a loss of coordination. Today, there are various treatments such as medications like levodopa, deep brain stimulation, and physiotherapy. However, these solutions have limitations. For example, medications often lose effectiveness over time. Some interventions are so invasive, and tremors remain too difficult to control. What is being researched? Some researchers are focusing on wearable devices with biometric sensors and technologies designed to stabilize movement using accelerometers or vibration systems to compensate for tremors. However, these solutions are still too expensive to be widely used and are often uncomfortable for the daily use. Why is this project important? First, it is important on a collective scale because Parkinson's disease affects more than 10 million people worldwide. And with the aging population, projections estimate that the number of patients could reach 25 million by 2050. It is therefore essential to address this issue within public health policy. On an individual level, Parkinson's disease prevents simple daily tasks such as writing, eating, or getting dressed. And for the patient, this loss of autonomy impacts mental health, self-confidence, social life, and overall quality of life. It also affects the patient's family and caregivers. It is therefore necessary to develop portable, non-invasive, and affordable solutions. Smart gloves could provide real-time assistance, improved motor control, and continuous symptom monitoring. This could help doctors better track the progression of the disease thanks to the data collected by centers.
The aim of this project is to design a smart glove capable of detecting hand tremors in real time, analyzing their frequency and intensity, and then reducing their effects through a stabilization system. The glove should be lightweight, comfortable, rechargeable, have long battery life, be easy to use in daily life, and affordable. The final goal is to improve patients' autonomy without any invasive procedure. We can break down our project into several distinct objectives in order to address them step by step. The first objective is to develop a sensing system with accurate sensor capable of detecting tremors in real time. We aim for reliable measurement of tremors frequency, amplitude, and duration. Our second objective is to create a stabilization mechanism to reduce tremors using vibrations and counter movements. And our final specific objective is usability and comfort testing, meaning comfort, ease of use, and patient acceptance of the glove. We want the glove to be wearable for several hours in a day. We want to use a biometric sensor, a haptic feedback system, and artificial intelligence to analyze the evolution of symptoms. Our gloves will therefore include accelerometers to measure movements, gyroscopes to detect rotations, and microcontrollers for data processing. Let's now go into more detail about how our gloves works. The first step would be the detection of hand movements using sensors. This data will then be analyzed by an algorithm to differentiate normal movements from those linked to Parkinson's disease. The last step is compensation. The glove will activate small vibration or micro actuators to stabilize the hand. We also want to use a mobile application to visualize the data, track symptoms for healthcare professionals, and adjust the glove settings. If this smart gloves project for Parkinson's disease is successful, the impacts could be very significant. First, on a clinical level, Patients could regain more independence in their daily lives. The glove could help reduce certain tremors and improve simple actions such as writing, eating, or holding objects. Then there would be a physio- psychological and social impact. People with Parkinson's could feel more confident and less dependent on those around them. Families and caregivers could also be relieved in managing the disease on a daily basis. From a medical perspective, the data collected by the glove could help doctors better monitor symptom progression and adjust treatments more precisely. Finally, the commercial impact could be important. The glove could become a portable, accessible, and less expensive solution compared to some current therapies. With the aging population and the increasing number of Parkinson's cases worldwide, this type of technology could see strong demand in the coming years. We anticipate the technical challenges that could arise. Problem 1 is detection accuracy. The system could have difficulty distinguish between voluntarily and involuntarily movements. To address this, more advanced artificial intelligence models could be used, and the algorithm could be trained with patient's data beforehand. Problem 2 is battery life. The glove could consume too much energy, so one alternative would be to optimize the sensor and use low power components. The glove could also switch to sleep mode when it is not in use and activate certain functions only when movement is detected. This helps increase battery life and makes the device more practical for daily use. Problem 3 is user comfort. The glove could be too heavy, too rigid, or uncomfortable. To address this, flexible materials such as medical silicone or breathable elastic fabrics could be used. We could also try to miniaturize electrics components using microsensors or lithium polymer batteries to make the glove lighter. Problem 4 is a regulatory challenge. As this is a medical device, it will be necessary to comply with safety standards, data protection rules, and medical regulations. To do so, we will collaborate with specialists and regulatory experts, and we will gather feedback from further users in order to get their input on the glove from the early stage of the design process. In conclusion, this Smart Gloves project for Parkinson's disease aims to combine technology, artificial intelligence, and healthcare in order to help patients better control their tremors in daily life. Thank you for your attention.